find the solution of the differential equation. So 1 by x integral 0 to x f of x dx whole square is equal to f of x into f of 0 for all x belongs to 0 to 1. So first we will simplify this as one more step. So integral 0 to x f of x dx whole square is equal to x square f of 0 f of x. We are bringing this x to right side. So we will consider g of x is equal to integral 0 to x f of x dx. So if I differentiate this, g dash x will be, so if I apply differentiation property, d by dx of x into f of x minus d by dx of 0 into f of 0. So this is d by dx of x is 1, so f of x, d by dx of 0 is 0, so f of x is what we have. So g dash x is f of x. So what we have is g of x whole square is equal to x square f of 0 f of x. So differentiate this. If I differentiate this, this is 2 g of x into g dash x. So if I differentiate here, f of 0 is constant, so f of 0 we can bring out, and then these two terms are there, so x square f dash x plus f of x into 2x. So 2 into g of x g dash x is equal to, so here we will have x square f of 0 f dash x plus 2x f of x f of 0. Okay, so g of x is integral 0 to x f of x dx, and then g dash x is f of x. So 2 f of x into g of x is integral 0 to x f of x dx is equal to x square f of 0 f dash x plus 2x f of x f of 0. And then see, let's say if I want to simplify this further, so divide this by f of x first. So integral 0 to x f of x dx is equal to x square f of 0 f dash x by f of x plus 2x f of 0. That is what it is. So okay, so if I see this, so that first equation integral 0 to x f of x dx will give me plus or minus x into root f of 0 into f of x, right? So if I try to simplify this, so it will be plus or minus x into root f of 0 f of x is equal to x square f of 0 f dash x by f of x plus 2x f of 0. We can cancel one x throughout, so it will be plus or minus, and root f of 0 also. So we'll have root f of x is equal to x root f of 0 f dash x by f of x plus 2 root f of 0, right? So let's say root f of 0, we'll call it as some constant. So root f of 0 is equal to constant, some k. This constant we are assuming, only to simplify the calculation we are assuming like that. So and even f of x will consider as t square because root f of x is there, right? So f of x equal to t square. If I differentiate this, f dash x will be 2t dt. So if I try to do this calculation now, so what we have is plus or minus t is equal to k x into f dash x is 2t dt by t square plus 2k. So we can cancel one t, So and then if I this is constant, right? So we can, if I multiply this whole thing by t square, I mean by t, so t square is equal to kx, I mean 2kx dt plus 2kt. So this is plus or minus t square minus 2kt is equal to 2kx dt. So this is, I mean this is dt by dx, right? Because we are doing f dash x, no? So dt by dx, so dt by dx, so dt by dx. So if I regroup the variables, so 2x by, I mean dx by 2kx is equal to dt by t square minus, I mean plus or minus t square minus 2kt. So this is dx by 2kx equal to dt by t square minus 2kt, and other differential equation will be dx by 2kx equal to dt by t square minus 2kt. So this we can solve by partial fractions, right? So this is 1 by 2k into integral dx by x, I mean integral of dx by x. So this is again integral dt by t into t minus 2k. This we can do by partial fractions. So this is 1 by 2k integral dx by x is equal to integral dt by minus t into t plus 2k. So this we can solve by partial fractions, and this is 1 by 2k into ln x is equal to, this is 1 by 2k into, so if I write the difference of these two, I will get that, right? So ln t minus 2k by t plus constant, right? So we will write ln c. So this is first. For the second one, 1 by 2k ln x is equal to minus 1 by 2k ln t by t plus 2k plus, let's say we'll write ln c as a constant. So we can cancel 2k, so we'll multiply this, so this is entirely k. So ln a plus ln b, ln ab, so this whole thing is some constant. So what we have here is this is equal to this, right? So x is equal to t is root f of x, so root f of x minus 2k, I mean 2 root f of 0 by root f of x into some constant. I mean don't write k, this is k, right? So okay, we can write this as k, instead here will write f of 0, so root f of 0. So there is one answer. Other answer is x is equal to, so ln k by, here we will have ln a minus ln b, ln a by b. So k by root f of x into, this will come to the numerator, right? So root f of x plus 2 into root f of 0. This k and this, okay, we will write k dash. So that there is no confusion between constant, because here what we are assuming k is root f of 0, right? So that root f of 0 we are replacing here. So we got f of x is equal to some function, right? So if I rearrange this, I will get f of x is equal to clearly a function. So the solution of the differential equation will have two solutions.